Alright guys, it has been quite a while since a full-length video. For the past few months, I've been working on a few different projects, and most recently, I've also been learning SolidWorks. In the past, I was using Onshape for all my CAD design. This video will be about one of the first real projects I've been making with SolidWorks, a rotary broach for my mini lathe. Here in SolidWorks, I have the assembly of the rotary broach made. There are only 3 parts to be machined. I've also made the drawings needed to machine it. In total, it has only taken a couple of hours to design, but much longer to actually make. Here in this split view, this is the taper that goes into the tailstock. Then we have a thrust bearing, then 2 ball bearings with a screw and washer to hold it all together. Then there's the housing. It has a 1-degree angle on the bore and face for the cutter holder. That angle is what makes it able to cut. Here's a clip of one of the runs that I did in aluminum with the rotary broach. You can see it wobbling around. That is from that 1-degree angle. Here's just the housing part by itself. This is studded for M4. Here's the tool holder by itself. Both these holes are also studded for M4. Then on the back there will be a M3 studded hole. This hole will be used for if I need to push out a stuck cutting tool. This front hole is drilled to 4mm for my current high-speed steel blanks. In the future I can make bigger ones if I need to though. And then I have the taper. This hole is studded for M4 for that retaining bolt. Then the back is tapered to Morse taper 1 to fit the tailstock. And that's about it. This has been an overall pretty simple project. The designing and machining was pretty light. Next, you'll see all the machining work. First part I'm making is the rotary broach housing. I did most of the outer profiling off camera. It was tricky to do since the stock that I had on hand was quite a bit bigger than I needed. And with a small lathe, it would have been pretty hard to film. I'm starting off with a center drill. Now pre-drilling with a 1/4-inch drill. Then drilling with a 1/2-inch drill. And finally, I can bore the size to fit the bearings. Here's the drawing of the housing. You can see the diameter, tolerance, and depth I'm trying to get to. This takes a lot of passes. Pretty much all the footage in this video is sped up to 5x speed. If it was 1x speed, it would be about an hour-long video. And to be honest, I wouldn't want to watch that either. Now I'm getting close to the final size, and I actually overshoot it. I ended up having to put shims into the bore to get the bearings to be a snug fit. Now comes probably one of the more sketchy setups I've done. To get the 1° angle on the face and the bore for the tool holder, I'm using a 1° angle block in between the chuck and the face of the housing. I have it tightened as much as I can get it, hoping that the angle block does not go flying out. I face the end to the 1° angle, and I can start drilling to the 1/2" bore. This mini lathe doesn't really have enough power for this 1/2" drill in steel. It ends up stalling quite a bit. Then over at the drill press, I made this 3D printed jig to hold it in place so I can drill the holes in the side. I spot drill with the center drill, then drill to 3.3mm for tapping. And as you can see, I have the bearings already in there. I decided to fit them before I drill these holes. Last thing on this part is to just tap it for M4 thread. I'm using a spiral flute tap. I found these cut the best while being cheap, and I can use it in multiple scenarios, whether it's a blind hole or a through hole. And now the housing is done. Alright, the next part that I'm making is the taper. This will be split into 2 setups. This first setup will be for the bearing mounting surfaces. Firstly here, I'm going to clean up the face and the OD. With those cleaned up, I can mark out the depths that I need to cut to. This first one is 1/2" depth for the ball bearings to sit on, then 5/8" depth for the thrust bearing, and 1" depth for where the taper ends. This first diameter will be 8mm. Going down from 3/4" stock, there's quite a bit of material to remove. This new camera angle moves the camera out of my way and would make it much easier for you guys to see. Sadly, some idiot keeps putting the coolant nozzle in the way. Now we're at the right diameter, and I can clean it up to the correct depths. Almost there, and of course, the carbide breaks. Now I've got a new carbide in. Off camera, I finished cleaning up the face, and I also touched up on the marking for the next depth. This step will be for the thrust bearing. The diameter is 1/2 inch. And again, I put the coolant nozzle right in the way. At some point I would realize. Now that is right spot on, but I want the fit to be a little bit looser so the rollers on the thrust bearing actually spin freely. So a quick cleanup pass and that is done. It fits perfect. Next I've got to drill a hole in the end for the retaining bolt. I'll drill to 3.3 millimeter, then tap for M4. And yes, I run coolant on pretty much everything. Just wanted to get that tap started with the drill chuck to make sure it's straight. Then I can use the hand chuck to finish tapping it. Quick chamfer of the edges, and this setup is done. Now to mark where the taper ends, and where I need to part it off. Watching this back while editing, I'm surprised at how much the parting tool moves under the load. I suppose I used some coolant. Now I'm facing off the end I just parted to prepare for the next step. Here's the drawing quick for the next operation. With having such a small area to clamp onto, I have to get it running true with the dial indicator. After several back and forth taps, I finally get it to where I'm happy. Then I can use center drill to make a hole in the end to use the live center. With the live center in place, I can safely turn down the OD. Now I've got to change the angle of the compound slide. I hate doing this on this lathe because you have to retract the compound slide all the way to get to the bolts. I've started to actually 3D print little angle plates so I can easily set the correct angle that I need. Here I'm cutting the taper, and to get an even feed rate, I'm using a hand drill to drive the compound slide. Now I've got the majority of the material removed. For this last pass, I will turn on the coolant to get a very nice surface finish. Then to finish it off, I'm going to turn down the end where the ejector bolt and the tailstock will push up against. A few chamfers on the end and we can test fit it. Now out of the chuck and all cleaned off, it is a perfect fit. It stays in snugly and it pops out when I move it all the way back. Now for the last part, the tool holder. This would be made out of aluminum, while all the other parts are made out of steel. Coolant on the aluminum is probably not needed, but it helps get that nice surface finish and helps the chips not stick to the carbide as much. And that is a perfect fit. I just got a chamfer and part it to length. Sadly, my phone ran out of storage right at the start of the cut. Almost done with this part, now I just have to face the end. Quick chamfer, and then drill in the 4mm hole for the cutters. Back over the drill press, I can use another 3D printed jig to hold in place while I drill the holes in the side. This bit of footage I only sped up to 1.5 times speed. Now I can finish it off by tapping these holes to M4. The diameter is small enough I can just tap all the way to the other side. Then all the parts are done. I will not show me making the cutter because that is a lot of little cutting with the Dremel and is very hard to film. Here I'm drilling out a test piece to test the rotary broach on. I'll drill it up to 3mm because I'm going to be making a 3mm hex. I ground the cutter to be just slightly bigger than 3mm to give a good fit on the Allen key. It is certainly cutting into the aluminum. The first time ever using a rotary broach, it cuts decent, but definitely could be better. You can see the hex is well formed and it fits snugly onto the Allen key. Overall, it turned out pretty good. Alright, so here's the finished rotary broach. It's pretty nice. Fitting smoothly. And this fits in very well. The cutter did not cut the best because it's supposed to be a little bit concave, but I did not grind it quite enough. Focus. Yeah, it's a very quick grind on Dremel. I didn't put much time into it. Soon I will make a better one. Yeah. Turned out pretty nice. Let me know what you guys think. Thanks very much for watching. See you next time. Bye.